Okay, I will get us started. This is recorded, so maybe some people are going to join us later and they can even peek in on the recording. We got to figure out how to distribute it. Welcome to our first ever seminar series on data-driven wildfire research. This series was born out of a conversation Margot Gerritsen and I had with Stanford Data Science Director Chris Menzel regarding how so many of the important problems in wildfire research are data-driven. I think it goes without saying, in recent years, wildfire has gone from an infrequent and distant news item to a center stage issue spanning many consecutive weeks for urban and suburban communities. Frequent wildfires are changing everyday lives in California in numerous ways, from public safety power shutoffs to hazardous air quality that seemed inconceivable as recently as 2015. Moreover, elevated wildfire risk in the Western United States and similar climates globally is here to stay into the foreseeable future. This seminar series was born out of a desire to engage the broad community of researchers at Stanford studying wildfires spanning all of the academic schools with the Stanford data science community. It is our hope that this series will highlight how solutions to many problems of interest in wildfire research require a data-driven approach. Our hope is to ultimately create an ongoing dialogue and series of collaborations which make headway into several critical areas of interest in wildfires. We hope to keep these seminars on Monday informal and as dialogues. Chris, in fact, today has suggested he's happy to be interrupted during his presentation. And we hope they will be dialogues rather than one-way conversations. I've asked each speaker to take 20 to 25 minutes to describe a particular area of wildfire that they are interested in and they think is important. And we hope to then, of course, leave 20 to 30 minutes for a Q&A session and discussion with the audience, discussing the problem presented and any other nuanced things that come up. I am thrilled that we have Chris Field here today to kick off our series. As most of you are probably aware, Chris is director of the Woods Institute for the Environment here at Stanford. Chris's research focuses on climate change, especially solutions that improve lives now, decrease the amount of future warming, and support vibrant economies. His recent projects emphasize decreasing risks from coastal flooding and wildfires. So today, Professor Field will speak on simultaneous management of fire risk, carbon storage, and human and ecosystem co-benefits. So take it away, Chris.
Thank you very much, Derek, and thanks everybody for joining. What I'd really like to do today is lay out some aspects of the fire landscape solutions, and what I really want to do is ask the question of whether we're looking at a landscape that is mostly about finding win-wins, or about whether we really need to confront some challenging trade-offs. I have a few slides in a kind of a rough outline format, but as Derek said, I'd be happy to be interrupted, and I'm happy to have this feel more like a conversation than like a lecture. I'm most interested in mapping out a vision of how we, in California especially, can get the challenge of the exploding wildfire risk under control, and how we can use that at the same time to solve other critical problems. I'll share a couple of slides, and please interrupt if you have a comment. So from my perspective, why didn't the slide advance? There are really 5 issues that we need to consider when we talk about wildfire solutions. And I'm sorry, get the people off of my slide. Okay, now I'm set. And we often don't talk about all 5 together nearly as much as we should. Of course, the main thing people think about is the near field risk to life and property, including ecosystems. Increasingly, it's been clear, especially in the California context, how much risk there is from the far field effects of smoke. And when we think about what we want to do to intervene, some of the interventions have the possibility to increase carbon stocks potentially, and we're seeing many more policies oriented around increasing the amount of forest carbon, which has a wide range of clear trade-offs with decreasing the fire risk. Many of the interventions that could be undertaken to increase carbon stocks don't necessarily protect or expand high quality habitat. Some do, trying to figure out where those overlaps occur. And of course, there are lots of people involved in all aspects of California's wildfire ecosystem lifestyle interface. And many of the questions involve what those people are going to do in the future and how they are going to interface with the forest. No question, Derek's already said that the area consumed in wildfires really exploding. One of the things that's dramatic from the California plot is how it's really only been since 2017 that we've seen something that is clearly a change from the long-term trend. And part of the reason that we're behind this issue is that it emerged so explosively. And when we think about it in the context of the incremental drivers, this is a really important illustration of how much there can be a threshold, and things can change dramatically as a consequence of passing that threshold. But it's also important to note that we've only seen 3 years of super high wildfire activity, and it's likely that we'll see some years of low activity in the future. Here's CAL FIRE's list of the 20 largest fires. As you all know, 5 of the 6 largest fires ever were in 2020. The only California wildfire ever to be over 1 million acres in a single fire complex. And of course, the damages also are highly concentrated in the fires in the last few years. Suppression costs go along with the area burned, indicating the effects not only of the larger area burned, but the increasing number of people in the wildland-urban interface. One of the things that strikes me as really important to talk about is whether or not we're headed for an environment in which this problem goes away because we've burned up everything. If you look at the total area burned in California since 2001, this is just adding up the yearly totals. It's not accounting for places that have had more than one fire, but it's on the order of 19 million acres. And since 2011, it's been 11 million acres. California's got about 33 million acres of forests, about 15 million acres of chaparral. So, I mean, if we said, oh, these fires are mostly in the forest, what's the average time through which we go through all the forest and are ready to go back again? It would only be around 8 years. And if we took the sum of forest and chaparral, it's still on the order of 10 years. So when we talk about things like dealing with fuel accumulations, it's really important to recognize that in some ways we are on the trajectory of having the wildfire activity occurring at such an accelerated rate that some aspects of the problem are sort of solving themselves in a frustrating and non-satisfactory way. But we may actually be looking at a future in which we really hardly have any forests, especially in the most fire-prone lower and mid-elevation montane regions that haven't burned recently. I think everybody knows the pattern of deaths from wildfires. The vegetation map of California. I want to highlight a couple of important features. One is that most of the wildfire activity really is concentrated in the area that is identified on this Kukler map as oak woodland and mixed conifer. It's mostly in lower elevation forests. We've historically had a lot of fire activity in chaparral. And one of the things I've been thinking about the last couple of days that strikes me as potentially important is that area burned in chaparral fires has actually been going down. There are a couple of climate and habitat related reasons for that. But I think a lot of it is that the firefighting enterprise in California has figured out how to deal with chaparral fires in some fundamentally important ways that we haven't yet figured out for forested areas and need to. There are 4 factors that I want to point out before we get too far into this. The first is a topic that I call zombie forest that Avery is going to talk about next week. And it has to do with the fact that we've already experienced enough climate change in California that there has been substantial pressure for ecosystems to shift to cooler habitats, either upslope or further north. And we have quite a substantial area of forest where the climate has already changed enough so that those are no longer appropriately forest, or you wouldn't expect forest to regenerate in those places. The forests are essentially the living dead museum ecosystems that will eventually be replaced, presumably by fire. We also are seeing lots of other climate impacts on tree mortality, on tree density. And one of the real questions for the future is what kind of ecosystems should we be thinking about in the future? And I would argue, very clearly past the point at which preserving some kind of historic set of ecosystems is the desirable goal or even a possible goal. Of course, it's super important in the context of wildfires that we're in a non-steady state in terms of fuel accumulation as a result of past fire suppression. In fact, I'd argue in many cases it's rapidly going away, and also the number of people in the wildland-urban interface. Here's a summary from, it's now 7 years ago, about the fire trends in different ecosystems. And it highlights what was already a rapidly increasing amount of area burned in the Sierra Klamath Cascade in the light blue, but also I think this really interesting decrease in the area burned in Mediterranean California, oak woodland and chaparral. And that I do think reflects some progress in getting ahead of chaparral type fires. The political context in which these fires occur is, of course, really important. About 60% of California's total forest area is publicly owned. In the state of California is about 46% publicly owned, and large amount of the recent wildfires have been in national forest, but a large amount have been in the part of the state that is not publicly owned. The final piece of kind of setup that I want to provide is these data on the percentage fire return interval departure. This is basically how far we are from our understanding of the historic fire regimes in different parts of the state. And positive values in the blues mean fires are less frequent than they were historically. Negative values in the yellows and red mean they're more frequent than they were historically. And for people with a long memory of thinking about fires in California, remember that back in the 1970s, there was this argument that we were seeing so much risk from chaparral fires because we had done fire suppression, and that had resulted in these explosive large area fires. And that if we could get back to having smaller, more frequent fires in chaparral, we'd be in a more fire safe situation. The thinking on that has really dramatically changed. So now there's a understanding that historically there are probably very few fires in these Mediterranean chaparral type habitats, and that the reason for that is there were almost no ignitions, that people weren't setting the fires, and there's very little lightning in these habitats. And the kinds of ecosystems that resulted were these truly majestic chaparral stands where early settlers described manzanitas with trunks as thick as a person's body. In Montaigne, California, the situation is very different. And that's the part of the state where some combination of fire suppression, a lack of indigenous burning has resulted in very large fuel accumulations and a very large departure from the historic fire regime that essentially sets us up for the kinds of explosive fires that we've seen. I think all of this interfaces with a dynamic and importantly evolving view of how to maintain appropriately natural ecosystems. And I think if you look at the history of U.S. conservation, starting back with John Muir, but certainly reflected in this 1963 Leopold report, that was the idea that the right way to do environmental protection was to mainly step back and to allow nature to take its course. And even in 1963, the Leopold Commission to the National Park Service was recognizing that there are some disturbance adapted biomes that need to be managed for disturbance. But I think this thinking that the way to preserve habitats is to keep the people out really is an important legacy to deal with. And as we think about moving forward, I think it's going to be really important to recognize not only the pressure that climate change is imposing, but the fact that we've never really had static ecosystems that were maintained in an ongoing state in the absence of human impact. And it's particularly true in the case of indigenous fires. The best estimates are that we, based on fire scars on tree trunks, may have had pre-European fire at the level of about 4 million acres a year in California. So more or less the same amount of burning as we saw in 2020. And then many of the reports of the early Europeans in California were of a tremendous pall of smoke. Essentially, the state was just covered with smoke in the summer and fall seasons. And if you contrast that with the amount of prescribed burning that's occurring now, it's a tiny fraction. This is from Rebecca's last year paper showing that in the context of historical burning, that was probably at the scale of a few million acres per year, that recent prescribed burns executed by CAL FIRE have been on the scale of 10 to 20,000 acres per year, with only about half of the planned burns completed. So a tiny, tiny fraction. When we start talking about managing the risk, super important to keep in mind this, the new appreciation of the far field risks from smoke exposure and the nationwide implications. Our whole infrastructure for fighting fires is built around the idea that if we protect the spaces closest to the buildings and the people, that we'll have done our jobs and we don't need to worry about remote areas. But the fact that the overall impacts on human health and on economic prospects are probably greater from these smoke effects than from the near field damage to structures. Really, it means that we need to change the way we think about remote fires, especially. And I would argue that as we think about a new paradigm for fire management, this distinction between the near field and the far field effects should be one of the first things that gets tackled. I already mentioned that there has been a rapidly growing increase in using forests as a net sink of carbon. And I would say that is structured by what seems to me to be a exceedingly optimistic perspective on where we're headed as a consequence of both the fire risk and the climate changes. The recent surveys have mostly all shown that California's been a net source. California forests have been a net source of carbon to the atmosphere in recent years. And that's mainly been driven by tree mortality and fires. And it's not impossible that can be reversed, but there is a really big and ongoing debate about the extent to which you can both manage to decrease fire risk and manage to increase carbon stocks. And the the paradigm that is an open question is whether you can manage for a park-like forest with a few big trees and not much understory vegetation, and end up with substantially more carbon than you get in the sort of crowded forest ecosystems that we have now. And I would say that the answer to that is far from clear. An additional element that's impacting the way we think about the carbon cycle now is, of course, as ecosystems are shifting to higher elevations, that basically the amount of area that's available for forest decreases as you move higher up the mountains, and especially as the high biomass, mid-elevation mountains ecosystems move up, the potential for storing large amounts of carbon is going to go down. And then a final component on carbon storage that we haven't thought very much about is what's equilibrium biomass look like as the climate shifts, and particularly as we have greater aridity as a consequence of the greater evaporating power of the warmer atmosphere. Should we be thinking about shifting toward managing ecosystems for lower carbon contents? When we think about habitat quality, there's such a diversity of issues that we're trying to take advantage of. There are a few iconic species like the spotted owl where it's clear that old growth, undisturbed ecosystems are absolutely critical. But then there are a wide variety of ecosystem services like carbon storage where it's much less clear that keeping humans out of the picture is going to be a useful component. So how do we begin to thread all these things together? I think it's useful to think about the accept, resist, direct paradigm. And are we going to be managing for trying to keep things the way that they are now? Are we just going to let ecosystems evolve the way they want to evolve? Or are we going to try and shape ecosystems so that they end up where we want them to end up? And I'm going to go on a little bit of a personal journey now about where I think we ought to be headed. And I want to start by talking about what you might regard as a source of implicit bias that comes from my background. This picture of my father at his sawmill in northeastern Wyoming is around 1970. And I know many of you have heard me joke about the reason I became an ecologist is because I had so much forest destruction to make up for, but that's actually not the way I think about it. My father and everyone in his community really understood themselves to be stewards of the forest. And whether or not they were responding to a series of incentives that led them in the directions they went. But I really do think when we look at next stages in managing fire risk in California, that finding an appropriate role for people in the forest is going to be really transformative. And I think the keys to the solution are very likely to be in the area of empowering and incentivizing local communities to really be the stewards of the forest. We've operated for centuries under a forest utilization paradigm that I think has been, it's been overall destructive in the sense that, the only financial incentive was to remove the biggest, best trees. And what we're going to need to move to is a paradigm where the incentives are aligned with managing the risk from fire, managing the habitat values, managing the carbon stocks. And there may be some offtake potential, but it can't be the only criterion moving forward. So in the context of that background, here's the trajectory of forest harvests in California over the last, the last 70 years. You can see we've gone down from around 12 to 15 million cubic meters per year harvested to 2 to 4 million cubic meters per year harvested, and harvests on national forests have pretty much gone away. The the decrease in harvest has been pretty much independent of the harvesting method. And, I think we tend to think appropriately about timber harvesting as an overall destructive influence on the environment. There's no question that the partly as a result of technology, partly as a result of what the incentives were, that it has been really, really destructive. But I'd argue that it doesn't necessarily need to be in the future. This is a photo of Civilian Conservation Corps, I don't know what you call inductees doing forest replanting on a clear cut. And I think the paradigm of something like the Civilian Conservation Corps being the dominant role of peoples in the forest really has a lot of opportunities moving forward. Before I leave the forest industry part of this, I want to emphasize that in recent years, the total activity in California has been almost the same in wood products and bioenergy. And when we look at what should happen to wood fiber that's removed from the forest in the future, I think they're really, really important opportunities in the bioenergy space, not because wood fiber is a great source of reliable electricity and it's expensive and complicated to deal with, but because it's a way to process large amounts of material that are very difficult to process otherwise. The experience California has with biomass to electricity is, relatively well established. Biomass from forest provides about 3% of current California electricity, but it's an amount that's been either steady or going down in recent years, partly because the incentives have been going down, and partly because the market for renewables is getting to be so cost competitive. And if we are going to continue to direct forest products toward electricity, it's going to have to be as a result of new incentives to do that directly, and not because biomass can compete with the increasingly affordable wind and solar. But there are really nice mature technologies that have evolved to take advantage of forest biomass for either electricity or combined heat and power, as this plant in Finland illustrates, or if any of you wanted to go out and buy a 100 kilowatt wood electricity generator, you can do that, and it arrives in a couple of shipping containers. Or even if you wanted to do wood pellets in your home, you could do that with modern systems that provide a integrated solution at moderate cost. But one other thing that I think it's important to talk a little bit about before we leave the wood fiber end of this conversation is that when we look at the most difficult to decarbonize parts of the economy, they typically end up in places like cement and steel, which are obviously used for construction and present some deep, deep challenges for decarbonization. And in some cases, those products can be either augmented or replaced by manufactured engineered wood products. Cross-laminated timber shown in the upper panel are feasible to make from relatively small wood harvested, and then things like the oriented structural board in the bottom can be made from basically any kind of forest materials, and those technologies can be combined into structures that are now more than 20 stories tall with wood construction, and provide a way to provide some opportunities for long-term carbon storage at the same time that we're looking at potentially significant decreases in the amount of concrete and steel that are used for construction. And then a final set of technologies that I want to just remind people about being relatively mature are things like this. They're called masticators or forest grinders. And when we look at removing the accumulated forest fuel accumulation in many of California's forests. I think it really tremendous opportunities for this. If you've been on any of the trails around here lately, you will have seen large amounts of material that, especially close to the trails, were were cut and ground. And in many cases, it is going to be too expensive to remove wood fiber for biomass electricity or for wood fiber manufacturing. But we really do have an increasingly mature set of technologies for just going into the forest and reducing the fuels, returning the organic matter to the soils in a way that has the potential to represent what the CCC equivalent would do in the 2020s and 2030s. And my sense is that the deployment of this kind of potential is really at the very early stages. We haven't yet stepped up to the kind of sober appreciation of what it's going to cost to deal with forest fuel accumulations in the short term. But I think the challenge really is one of the politics and not a challenge of not being able to do it. Even on extremely steep slopes, the technology is now to the point where fuel accumulation can be done safely. The other set of issues that hasn't been totally worked out, however, is the issue of how you think about maintaining the habitat values and how you think about the paired challenge of doing fuel reduction and habitat preservation in spotted owl habitat. And I think that's an area where there's going to need to be an incredible increase in focus. Let me just close with a couple thoughts. The issues are really different in different ecosystem types. In chaparral, I would argue that we've mainly figured out how to deal with fire risk. And in chaparral, especially, fire breaks can be incredibly effective. We're way behind the curve in the forested ecosystems, especially in the lower montane forests and oak woodland forests. And those are the areas where we're going to have to be the most serious about commitments to fuel reduction. There are some opportunities for prescribed burns for sure, but I don't see this being a problem that we can burn our way out of. Well, wildfire may burn us out of the problem, but I don't think prescribed burns are going to be the primary vehicle. And I think that's going to be because the fuel accumulation prevents it. I think that the sort of complexity of the political environment is going to continue to be very challenging. And prescribed burns need to be dramatically increased, but they need to be increased in the context of a portfolio of other kinds of changes. As I said earlier, I think that probably the most important thing we need to do is change the conceptual model for how people interface with the forest, the conceptual financial model for how people interface with the forest, and that we need to shift to a situation in which the forest protection resources allow individuals, companies, agencies to be focused on managing the forest to achieve a wide range of values and not just for extraction of products. There are opportunities for win-wins, but there are also some very clear trade-offs. And I didn't talk very much about it, but I think there's going to be a clear trade-off between prescribed burns and smoke. And as far as I can tell, the quantity and quality of smoke from prescribed burns is basically the same as from wildfire. And even if we manage that as well as we can, the smoke issues are going to be significant and probably hold back what we can do with prescribed burns. And then before I close, I just want to say that I don't intend any of this to suggest that forest management ought to be an alternative to doing a much better job with planning, zoning, and defensible space and strategic relocation, all of which are going to be absolutely critical for decreasing the loss of lives and property. But maybe more than anything else, I want to leave with the philosophical opinion that hands-off is the worst option we could pursue at this point, that we need to be much more engaged in making forests safe, and vibrant, and fulfilling the full range of ecosystem services. That's my thoughts. I look forward to your comments.
Thank you, Chris, for a lot of great insights on a range of issues on such an important problem. We can keep this informal, but if you'd like, you can raise your hand and call you and try to kick you in order. Does anyone want to start off our discussion with some questions for Chris?
Krishna.
Hi, Chris. Thanks for the talk. So in the middle, you showed some pictures of your father and the logging.
Just one picture of my father.
Okay, yeah.
Those other guys, I don't know who they were.
Okay, and you also told about the difficulties related to prescribed burning because of the regulations related to clean air. So would you argue for prescribed logging as an alternative or something to complement prescribed burning for managing wildfire risk?
Yes, that's basically the idea, is that I don't want to say prescribed logging, prescribed interventions for fuel reduction. And in most cases, I think those interventions should leave the big trees behind, which is kind of the opposite of logging. But there will be some places where mechanical fuel reduction in itself is the path forward. Other cases in which mechanical fuel reduction may make it possible to do later prescribed burns, and some cases in which the mechanical fuel reduction will also allow for the extraction of useful products, either for bioelectricity or for construction materials.
Great.
Noah.
Go ahead, Noah. Sorry about that.
Oh, sorry, I couldn't hear. Yeah, that was fantastic, Chris. Thank you. There were a couple conclusions that are a little different than some of the things I find myself saying in public, and so I want to check in on them. One about the prescribed burns, and the other about the chaparral. And so on the prescribed burns, and I don't have, other than Kari's group's work, I don't have any evidence, which is why I'm checking in. Like, to me, one of the advantages of prescribed burns is that they're with respect to the air quality, is that they're by definition happening at a time when the atmospheric conditions are less conducive to that kind of regional scale smoke events that we have during the uncontrolled wildfires. And so that, I guess my question is, what do you think about that as a potential advantage of the prescribed burns? I also mentioned Kari's work on the distributional impacts, but I'm definitely not expert in that.
Well, let me emphasize that I'm a big advocate for increasing the amount of prescribed burns, but I think there's going to be a limit to which we can take them. And I don't pretend to have complete understanding of the way the public dialogue about smoke exposure might go. Let me just say that it's clear that no matter how successful we are with a dramatically expanded prescribed burn agenda, there is going to be smoke associated with it. And that's going to be especially true if we do the prescribed burns in heavier fuel areas. And if we are to get to the scale of millions of acres per year, we're talking about an amount of fuel that's not, totally disconnected from the amount of fuel that was consumed in the last few years of very high wildfire activity. So what does it mean to be a strong advocate for increased prescribed burns? recognizing that there are going to be limits to how far we can push that. And, I think that we might be able to see prescribed burns up at the scale of several 100,000 acres per year, but that's still at least an order of magnitude short of where it would need to be. And I think that's what we would need to fill in with these other kinds of mechanical fuel reduction.
Okay, thanks. That makes sense. I'll go ahead, Marshall.
Actually, can I ask a follow-up question before Marshall gets in? So Chris, you presented some really compelling data early in your talk about, I think it was 11 million acres from 2001 to 2011, and then we're at 19 million another decade later. Is there a lot of historical data before that? Because I'd be curious, like how many million acres burned 100 years ago when we weren't suppressing so much?
Yeah,
And
so there are only two lines of evidence that I know of for that, and one is all these early reports of the smoke in the summertime in California, and the other is from fire scars on tree ring analyses. You can get some sense of both the historical fire return intervals that I showed in that one map, and also of the area burned. And that's where these estimates of maybe 4 million acres a year come from. So at 4 million acres a year, that means you burn through the existing forest stock on the order of maybe once every 5 years, because there's some forest ecosystems that are only reset by stand clearing fires. Some forest ecosystems hardly ever have fire. There's probably around 20 million acres that are in the fire prone area.
Okay. Thanks for letting me step in, Marshall. You're next.
Oh yeah, no worries. Thanks, Derek. And thanks, Chris. Fascinating and always educational slides. My question was following up on Noah's, and again, worrying that I'm saying some things out loud publicly that might be incorrect about prescribed burns. It seemed like to me that just reading the literature and trying to understand this, and I think the literature doesn't seem that well decided or quantitatively precise on these issues, but it would seem to suggest two channels through which you would get less smoke from a given amount of prescribed fire burn than you would from an out of control wildfire. One is I think the one we think about all the time when you don't get the canopy fires from the prescribed burns. And so it's a lower intensity fire that generates less smoke, maybe a different kind of smoke in a way that's important to understand, but less overall PM 2.5 are the key pollutants that we care about. And the second channel being this like multiplier effect you get, where if you enact prescribed burns on 1 acre, you get more than 1 acre of reduction in terms of future downstream wildfire risk, just because of the spillover effect of reducing the likelihood of fire. So I would have thought through both of those channels that you would actually get a lot less smoke for a given amount of prescribed burning than you would if that similar area would have burned in wildfire.
I think that's probably right, and I don't want to appear to be arguing against prescribed burns or against the efficacy of prescribed burns in decreasing the amount of area that's lost in wildfires. But I think there are at least two reasons to be really cautious about advocating only for a big increase in prescribed burns. One is that there really are a lot of areas where historic fuel accumulation makes it impractical to think about starting off with prescribed burns as the management approach. A second is that the whole concept of prescribed burns is sort of connected with the idea that we're trying to maintain an existing ecosystem in a setting where climate change is already shifting the boundaries of lots of ecosystem types, and whether or not it's even practical to do prescribed burns in these ecosystems that you could think of as zombie forests is far from clear. So I feel like we just want to have really bright caution lights flashing when we talk about using prescribed burns as the dominant method of decreasing the wildfire risk in the future. Also, in prescribed burns aren't really appropriate in some ecosystems. In chaparral, they don't really help. And in higher elevation forests that have an evolutionary history of stand clearing forests, they don't really help. Stand clearing fires, they don't help.
Great, thanks for the answer, Chris. Any other questions? I've got a couple myself, but I want to make sure everyone else. Noah, go ahead.
I want to. Oh, Alex, go ahead, Alex.
I mean, I was going to change the topic a little bit because there's a ton of questions to potentially ask. So, I just wanted to go back to what you were saying about carbon stocks, Chris, and the interactions there as one of your 5 issues. You talked mostly about above ground vegetation and the carbon stored there. I'm just curious what your thoughts are on or what you would say these different solutions might mean in terms of their effects for soil carbon, and how much that is an important angle for thinking about the carbon storage effects of this problem.
Yeah, that's a great question. And certainly California wide, I think that a lot of the opportunities for increasing carbon in ecosystems are going to be in soils, more in grassland areas. One of the things that's really striking when you look at the detailed ecosystem carbon budgets is how much of the carbon in most forest ecosystems in the temperate zone is in coarse woody debris and standing dead, fallen logs and stuff like that. And some of that's associated with fire risk. Of course, an awful lot of the fire risk is associated with the fine fuels, and those fine fuels can be reduced either with dry burns or with mechanical fuel reduction. If you do the mastication, the biomass stays in the forest, and some of that's incorporated in the soil. My sense is that the prospects for interventions that dramatically increase forest soil carbon are really, really limited. They have a very slow input rate and questionable impacts. Would any of these interventions result in dramatic losses of forest soil carbon? One of the evolutionary advantages of taking wood off most ecosystems is that wood's very low in the mineral nutrients that are necessary for building up soil carbon. And so as long as any kind of fiber removal focuses on the wood and leaves the leaves and roots in place, I wouldn't expect large decreases. But there are lots of aspects of where you might influence soil carbon. My guess is that overall the dominant influence on soil carbon stocks in California is going to be climate driven rather than management driven.
Great, thanks. So other people.
I'm gonna give Nona a last question, and I have one to make sure we get back to data driven to end our time here. So I know we're at 1:20, so if you have to leave, I want to respect your time, but if you want to stay on, I'd like to stay on a little here to hear Nona's question, at least have Chris touch on the data-driven connection here for our series. But go ahead, Nona.
Okay, actually, it looks like Mike has a question as well. Sorry, that should be a little bit better unmuted. So my question is maybe more about the devil being in the details, and it is the relationship between the timing of fuel reduction by mechanical means versus by prescribed fire. And, at least in our area, when people talk about doing mechanical fuel reduction, they want to do it in the spring to avoid starting a fire accidentally. But on the other hand, that's when the impacts to habitat are worst, and also the risk of spreading diseases is worst. So, maybe again, it's just a devil in the details issue, but prescribed fire does get around some of those problems.
Yes, there are a lot of details that we haven't really worked out. One of the things that I'll say is that if we improve the techniques for intervening to do fuel reduction. If some of those interventions are also sparking fires, then maybe they'll be prescribed burn type fires. The other thing that's worth thinking about is that we have a really excellent record of doing prescribed burns safely, but a lot of that is based on not doing the prescribed burns during the kind of the heart of the fire season. And as we look at doing more and more prescribed burns, there'd be additional challenges to be able to manage those in ways that are safe and effective.
Great, Michael, go ahead, give you a shot.
Thanks, Eric. Happy to have this be a longer conversation another time, but I'm curious, I guess I'm detecting perhaps some skepticism in the role of natural climate solutions in meeting, for instance, carbon neutrality goals here in California, at least in the forest areas. And I'm wondering if you could comment on your thoughts on the implications there.
Yes, I am skeptical about the feasibility of dramatically increasing the stock of carbon in California ecosystems without at the same time dramatically increasing fire risk. I'm skeptical about the feasibility of increasing carbon stocks in the long run in the context of both the fire risk and the ongoing climate change. So in terms of the implications for California reaching its climate change targets, and it is the context for a longer conversation, but I think that California is one of the places that needs to be alert to the possibility that natural climate solutions within the state's boundaries are unlikely to be major contributors to whatever the targets are.
All right, I'm going to close this out with a very open-ended question because this is data-driven wildfire research. That's the title of our seminar. Chris, you've covered a lot of ground today, and I think one of the ones that really struck my attention was you asked how are people going to interface with the forest in the years ahead, and the question is, how do we make a decision on that, right? I mean, if you could forecast what climate change is going to be or which way it's headed and which way vegetation is headed, do we have the data, or is certain data necessary to prescribe or to direct that path of how people interface with the forest?
Well, I think when we're data-driven, we want to make sure that we're open to the full range of where the data are coming from. And at this point, I would say the strongest, clearest political signals are that there is intense concern about the property and life risk from acute impacts of fires, and that we're going to see a massive amount of resources directed toward that. I think that we're in a historical moment where issues related to opportunities for rural and indigenous peoples is going to continue to get a lot of emphasis. And I think we're in an environment where finding ways to stitch together multi-part solutions to climate challenges is going to continue to get a lot of attention. So I think all of those fit really comfortably with the characterization of the wildfire situation that I've described. I'll be interested in what future speakers have to bring to the conversation about whether there are key insights about the way ecosystems work and the relative importance of ignitions versus fuel dryness, and lots of those things could give us a more highly resolved view of what the fire risk is. But I think from a policy perspective, my claim would be that we have abundant evidence that the challenge of wildfire risk is gigantic and immediate, and we have abundant information that a solution portfolio that emphasizes the big trends in what the perceived risks are and how we ought to be thinking about solutions, particularly the acute risk to people, and the emphasis on indigenous and rural lifestyles. I think that the other things I talked about, the carbon cycle emphasis, the habitat quality, and smoke, are also important, and they're going to be modulators, but I don't think they're going to be as important as the primary drivers from decreasing the acute damages and emphasizing rural lifestyles.
Well, that's great. Chris, thanks for just kicking us off, because I think you basically opened many cans of worms for us to be thinking about today. And I am excited to have Avery giving us a spin on zombie forest next week. And I think we have really 7 more remaining talks that will really probably pose more questions than your required answers, but really show that this is something that's going to take a multi-pronged and a very thoughtful, diverse approach to hopefully coming to some progress in the area of wildfires and making us, I guess, more resilient as a human species to what we're doing to our planet and how we face this phenomena.
Yeah.
So
well,
thank you for everyone.
Derek. Thank you, Derek, for setting it up, and thanks everybody for great questions today.
Yeah, thank you to everybody. Please spread the word out. We didn't want to put the Zoom link on the web, but most of you have it already. So please advertise and advocate for this, encourage people to attend, and we'll see you again next week. Have a great afternoon, everybody.
Thanks a lot, Chris.
See you guys.
Thanks, Chris. Thanks, Derek.